What is up, guys? In this video we're going to talk about homogeneous differential equations and how to solve a few. So let's get started. These types, they have the same degree. I'll give you some examples. So let's say you have this one, dy dx is equal to y squared minus x squared over yx. Here's what we got right here. So the degree that we have here is 2, and same thing for x. And if you notice that in the denominator y and x, when you add those up, you get 2 as well. So what this means is, from this end, when you have y, the same thing as having y equals 2 and then x equals 0. And the other one is the same thing as having x 2 squared and then y equals 0. So the degree here is 2. So here down below we have 1 for each. So this is how you notice that this is an homogeneous differential equation, because you have the same degree in both the numerator and the denominator. So how do we solve this? The first step is to identify the degree. I call it d. So in our specific case, it's 2. So let's get started. So now we're going to multiply both members, both the numerator and the denominator, by x and then to the second power. So if this was 4 or 5 or 6, here it will be 4, 5 or 6 and so on. So in our specific case it's 2. So here's what we're going to do. So let's get started then. So taking our expression, so it's 1 over x to the second power, and we're going to multiply by the first member, which is y squared, and then the second member, so x squared, and then going to divide that, same thing, so 1 divided by x squared times the second member. So this is, let me change colors, so this is y x. Okay, nothing new here. This is 1, so we haven't changed anything. So now what we do is we get this member to each of them, same thing here, so we can simplify the expression a bit. So let's do that. So we get y squared divided by x squared, right? Then x squared over x squared, and this is divided by yx over x squared, and this is the same. We have dy dx. I just let this out just for you to get a better understanding of what's going on here. But keep this in mind because we're going to need this later on. So let's continue. So now that we have this, let's simplify this a bit. So the first step is seeing elements that we have here that we can simplify. So we have yx, both squared, and then minus 1, because it's x squared over x squared. And the other one, we have 1x here, we have 2, so we get 1 out. So this is y and then over x. Okay, and this is equal to dy dx. So now that we got here, what we're going to do is use what's called the v substitution. Nothing to do with the derivatives for now. It's just a way for us to simplify the expression. Let me show you. So we have v. So what we are going to do is say that v is equal to y over x. And then the second step is to get y, it's equal to vx, and then have the derivative of that. So that's d dx of y, and then the derivative of this part, which in our specific case, so the first element is x, so the derivative is 1, so it's v plus, and then the derivative in terms of v. So it's dv dx times x. We're going to need this later on. So let's continue. So now what we're going to do is develop the expression just in terms of v, because we just said that v is equal to y over x, so we're going to substitute it here. So y over x to the squared, so that's v squared minus 1 over v, and that is equal to dy dx. But we also said that dy dx, it's the same thing as having v plus x dv dx. So we're going to equal both expressions to one another. So let's do that. So here what we have right now is v squared minus 1 over v is equal to v plus x dv dx. We can take this one to that other side, so we get v squared minus 1 over v minus v is equal to x dv dx. We can even rearrange these terms to get this one in, so we get v squared minus 1 minus v squared divided by v. We can cancel these two. It's equal to x dv over dx. Let's continue. So now we have, let's just simplify this a bit, get it cleaner for a sanity check. So it's minus 1 over v is equal to x dv dx. So now we have a separable differential equation. We can get the v with dv and the same thing with the x. So let's do that. So v dv is equal to minus 1 over x dx. And now we can continue to do the integration. So now we have v dv is equal to minus, we can get the minus out, and then it's 1 over x dx. And now it's the simple part. So v, it's v squared over 2 is equal to minus ln of x plus c. And what we do here right now is, now we get this second term to that end, just to leave the v alone. So what we do is we have v squared is equal to minus 2 multiplied by ln of x plus c. And now we can substitute the v squared to the initial element, which is squared. So this is the expression, minus 2 ln of x plus c. And since we have both these terms to the squared, it's the same thing as saying this one is squared and this one is also squared. So minus 2 and then ln of x plus c. So we can take this one out and get it there. So what we are left off is y squared is equal to minus 2x squared, then ln of x plus c. This is our final expression.